Okay, so this skills test for Module 7 involves building a simple circuit. Now, a simple circuit is just a electrical circuit that has essentially one source of energy. Usually, in this case, it's a battery pack. Could be just a single battery or some sort of a power supply. In this case, it's just a battery pack. And then it only has one energy consumer, which in this case is a resistor. So when you load up the simulation, you hit begin, you'll see your simple circuit. It's a loop. And you'll notice there's a couple of meters here. Now the meters are described in the introductory material, so I encourage you to go ahead and read through that and also read through the section about the battery pack. The first thing you're asked to do, well actually I'll just show you first of all how these meters are read. All you have to do is click on them. When you click on them, you will see in this case this is an ammeter. It measures current. It measures the number of charges that are flowing through it every second, and it gets a reading. In this case, it's in milliamps. The voltmeter measures voltage, essentially the amount of energy uh, dropped by each charge when it moves through a load. In this case, it's the resistor. So um, that's how a voltmeter works. And notice that they are wired differently. In the case of an ammeter, it's wired in what's called series. Charges have no choice. They must go through the ammeter in order to continue on through the circuit. If you disconnected the ammeter, no current would flow through the circuit. The voltmeter, notice it doesn't, it's not an integral part of the circuit. I could disconnect either one of these leads from the voltmeter and charges would continue to go around this loop. It wouldn't matter. So a voltmeter is wired across a resistor or across a load because its job is not to count the number of charges that are moving through the circuit. Essentially, it conducts a little interview. It stops a charge on this side of the load and it says, hey, charge, how much energy do you have? And then it gets an answer. The charge moves along and it gets interviewed again on the other side of the load saying, hey, how much energy you got? And then it compares those two answers and that which winds up on the display as being the voltage drop across that load. So notice that the voltmeter and the ammeter are wired differently because they perform different tasks. Now, the first thing your first task in question 1 is to take a close shot of your resistor and take a screen grab and upload it because it is important that your instructor knows the value of the resistance of your circuit because you're going to actually have to give the answer. So in question 2, you need to actually read this resistor and tell what the resistance value is. So make sure that if you didn't go through the read resistors skill builder, make sure to go back and do that. Now, moving on. Once you've read your resistor, you can go back to your full circuit and you've got to create a little table here that's going to be the number of batteries, the current, and the voltage. Okay, so it's very important you don't change your resistor. You keep the resistor the same for this entire data table. And what you're going to do is you're going to change the number of batteries. So in this case, I might start out, notice that there's 1, 2, 3, there's 7 batteries in this battery pack. That's fine. What you do is you write down 7 for your number of batteries. You would take an ammeter reading in milliamps. You'd want to convert that to amps. Okay, so milliamps, a milliamp is 1,000th of an amp. So to convert this into amps, what you would need to do is you would need to move your decimal place 3 places to the left. So 131 milliamps is the same thing as 0.131 amps. So that's the conversion. And then finally, you need to get your voltage reading. So you click on your voltmeter and get a voltage reading. Again, yours are going to be different than mine, so don't worry about taking my numbers. You're going to do it yourself. And you're going to do this for several different battery values. So once you've taken that first row of data, then go ahead and go back and choose a new battery pack. So now I've got only 2 cells, 2 batteries in my battery pack. Go back, take your voltage reading, take your ammeter reading, complete the table, and then you have to graph your information. So in question 3, you're actually going to graph that data. You're going to graph the number of batteries. So number of batteries on your x-axis, and you're going to plot voltage. See what your voltmeter read for those 5 rows of data. That's how you get question 3 taken care of. Question 4, you're going to do a voltage versus current graph. So you want to put current on your x-axis and graph it, screen capture your graph, and upload it to your instructor. You'll answer question number 5 as well. Now, in question number, then the next data table you need to create, you're going to, instructions are pretty well laid out. They tell you to click on your battery box and generate new battery packs until you get one that shows 4 batteries. There we go, 4 batteries. And you're not going to change this at all. So instead of changing the amount of batteries in this case, you're going to leave that fixed. Now what you will be changing in this particular activity is you're going to be changing the resistance. So with those 4 batteries in place, you can go ahead and, if you want to, take your take a voltage reading, or sorry, take a current reading. It doesn't even say your voltage reading because you're not going to change your voltage. You're keeping the same number of batteries. Take a current reading. You'll want to convert that from milliamps to amps, and then you'll want to read your resistance. Remember, read your resistor. Then once you've gotten all that data, you'll want to change your resistor. So switch resistor. Again, figure out what that resistance is and take another current reading. Remember, your batteries are still the same. So take another current reading, then swap out resistors again, etc., until you've completed your data table. You'll use your graphing program again. This time, you're going to put your resistance values on the x-axis. There's going to be resistance on the x-axis. This is for question 6, and current on the y-axis. And you want to have your current in amps, so make sure you are using the amps column, not the milliamps column. And then finally, question 7 is a little wrapping up kind of question. So that's how you use this particular interface. Again, make sure that you understand how to read resistors. That's a very important skill. You're going to need it again when you get to the lab activities for this module. And of course, make sure you understand the difference between a voltmeter and an ammeter.